Hi everyone, I hope you're doing well. It's a pleasure for us today to be with you here to present our work, EVALKIT here. Before to start, I would like to thank our mentors, Sufyan and Steve, are here, but also the ones who couldn't make it today. So today we can so this one, yeah, I just want to go a little bit into the context, like Steve just explained. We tried in the, for example, in the ECMWF reading room, which we have a lot of charts. We have a lot of plots that we try to analyze, to detect, for example, to analyze them and have more idea about what's happening in the weather forecasts. So this is why we try to develop this EVALKIT, which we have to compare a lot of models, as you know now in the and the progress, technological progress and scientific progress, we may have a lot of models. So we have to have a tool that can we can compare between them the narrative. As we all know, this code, all models are wrong, but some models are useful. So this is why we would like to introduce this, as we have segmented a lot of scientific community here use a lot of scripts and tools, so it's a little bit, it's not purified. So now we try to a little bit standardize this and give another tool, which is EVAKIT here with three. It's a toolkit that there's three tools there. The first one is the dynamic weather mapping visualization tool, which we try to have an interactive mapping. Second one is an interactive time series analysis tool where we try to use it for time series analysis for different models. And the last one is for probabilistic forecast analysis tools, which we try to analyze the ensemble models. Yes, before going to the EVALKIT, one of the major goals it was to try to include the Earthskate package in our workflow. So, for example, mainly for data acquisition, data retrieval, data logging. Secondly, for data processing, for example, calculating the time series. And last one is for Earthskate part for visualization, sample visualizations. Now, before I want to go a little bit into the terminology. Although you are guys better than us in this, but we try made basically to use to work with mass data, which is the archival system which stores a lot of decades of meteorological data and a lot of products. So for the Mars, we were mainly used with AIFS model, which is artificial intelligence forecast system, which is basically built on the machine learning techniques and data driven model. And ARFS, which is integrated forecast system, is mainly based. It's a physical based model which includes data simulation and system model. So we mainly worked with two types of deterministic or two types of type forecast. The first one is deterministic forecast, which present and interpret we have a forecast for a given initial condition. Yeah, for an initial condition. And for the probabilistic forecast, it's mainly based on the ensemble model, which is the we have multiple initial conditions, but give us a lot of ranges of forecasting. So we try to do some analysis for this type. And for the last part is here is we were working on two types of variables: the surface variable and the second one is pressure level variables. And for surface variables, we have the collision variables, which is the temperature, the total precipitation, and the wind gusts, and try to derive some other variables that would be useful. For example, accumulated precipitation, the wind speed, the daily maximum for some parameters. And for the last one, we have the pressure level variables needed, the pressure or pressure potential effect. It's going to be used for other parameters. Yeah, now I will let you with my colleague Nadia to present the basic.
So for now, we delve into the three products that we developed. So we have some recorded demos. So I will need to stop and play the demos. So I'll create anything. Yeah.
So these are videos?
Yep.
Yes.
Okay.
Yes. So the first tool is the probabilistic forecast analysis tool, which is a comprehensive suite in order to analyze analyze uh, probabilistic forecast using a suite of complementary plots. As you can see, we have meteograms, stamps, plumes, and CDS, which is cumulative distributed functions. So this is our user interface. Let's just play it. So we have three sections. The first section for the data retrieval from mass archive directly, the user can configure the request to send by choosing the data source, the model, the date, the time, the resolution. Yeah. And also we provided another option for more flexibility. It's to load local verify if you already downloaded them funds. Sometimes downloading data from mass archive directly takes a lot of time. So yeah, that's it, an example of retrieving data. And then we have the second section. I would just put it a little bit. Yeah, the sixth section for the plotting. So here we have the map, and when we click on the map, we automatically get the plot. Here we have a histogram, which is like a time series evolution of ensemble forecasts for each time step. And in each time step, we have the box plot with the quantized and the median. The second plot, the second plot is the rules that we appear speed it up here. Yes, this one. Here we have the blues, which is also an evolution of the ensemble focused overtiles with shading to cover the range of the spread of the ensemble forecast. So we have three shading range when the median would describe the central tendency of the variable that we plot. And all plots like this one and the previous one were made with Plotly, which support natively the zooming, the covering, planning, and like exploring data in depth. And then we have the CGR and the stamps. Just go here for the house, it's easier. Yeah. And here we have the clues. That was just so. Yeah. Yes, here we have the stamps. So the stamps are maps for different ensemble members together with the unperturbed forecast, which is the controlled forecast. And for all different variables, we supported unit conversion. For example, for precipitation, we can convert from meter to millimeter. For temperature, we can convert from Kelvin to Celsius. And we provided different color scales in order to assess the variation of the variable. And here we have the last one, which is the CDH. Yeah, which is the cumulative distributive function, which is used to see by the probability at which a specific finding exceeds the threshold. So I skipped the other parts because the training data is similar to all the three plots. Like what's changed is only the plotting section. Then we have the second tool. So the first tool was for probabilistic forecast. The second and third tool are for deterministic forecasts. So here we have time series analysis, which supports three this one. Which supports three type of comparison. The first one is comparison inter-movies, so we can compare EIFS with IFS. The second one is to click at a specific location and to click at multiple locations and compare for the same model between different locations. And the third one is to compare against observation. So I will flip the. Yes. So here we have the same first section, so to retrieve the data. So we choose the parameters, the modules, the time, the dates, and the steps that we want to use. And also we had a map so that the user can draw the bounding box or the geographic area he wants to load. Yeah, here. And once it's drawn, like automatically it gets updated in here. And once the data is calculated, it's retrieved, the derived variables are automatically calculated and are added to this list from which the user can choose the variable to plot. And this section we have observation. So the observation part is optional because observations are not always available. So if they are available, the user can choose yes, and they can either browse them or retrieve them directly from the SUFL. If not, he can skip this part. He can still use the interface in order to plot just the two models. So here we have the plot, for example, for the 2-meter temperature. We have the three models, the EIFS, the IFS, and the observations. Once we load the observations, we get the stations inside the boundary box, and we can select as many stages as we want. Yes, and also, again, Plotly supports many interactions, so you can display or hide whatever you want, zoom, hover on to see values, etc. And the last tool, on this one, it's the dynamic with a machine visualization tool in order to allow interactive exploration of different surface variables. So again, the first section is similar to the previous tool, so I will just skip it. So it's data retrieving from mass archive or loading from local files. And then we have this middle section to calculate some variables like the wind speed based on the 10U and the 10V components, or accumulated precipitation, or extremes, which is max and the mean for either the temperature or the wind gust. And we have the plotting section right here at the end. Yes. So once the data is retrieved and the calculators are done, in this section we have all the parameters are listed, so we can choose which one we want to plot. And for plotting, we have three types of visualizations. We have first the dynamic map, which is a map in which the user can hover. What's this one? Yes. In which the user can like zoom, pan, hover, and like explore the variation of the variable. Yeah. And here we have the second one, which is static map. So can I see it? Yes. The static map, which was done using EVALKIT plot. So this one, it's like easy for example, for reports or like quick presentations. The other one, it's like to investigate and to explore and to analyze thoroughly. And the last one, it's, one. The last one, it's animated. So it allows you to select multiple forecast steps and to see the evolution of the variable over time. So as you can, it's moving. And now, like we demonstrated what we've done for the 3 demos, but now we try to select 2 study cases in order to apply what we've done on these 2 study cases. So first we have the heat wave in June 25, it's Southeast Europe. So here we have the dynamic map used to plot the wind gust. And as we can see, yes, so it's here. As we can see, we have a green area, so it's calm in this part, like calm with speeds. Then we have the temperature here. We have also again the dynamic map and the time series plot, and we can see that we have here, here we have orange and yellow colors, which is in the 30. If you see the color scale, yes, around 30 degree. And like this, what we observed, the map aligns perfectly what we've done in the time series. As you can see, the maximum, the peaks like are around this value. So here we leverage 2 of our tools, so the dynamic map and the types and the time series. And the second event is Storm Flores from 4th August 2025, which affected the northern part of Scotland. Here we used the animated dynamic map, and we can see the storm was moving now. Okay. So we can see that's like the evolution of the storm using this work. Here we have the probabilistic steps. We have the 50 members, so it might be a little small, but we have here the 50 ensemble members. And if you focus on the area of Scotland, you can see it as the yellow color, which appears on all members. And here we have the wind gusts, both from the dynamic map and from time series. And we can see that we have like higher values around 40 meters per second in the area of the storm here, and the peak also in the type series. Yeah. So to sum up, what we built, it's like a comprehensive tool to facilitate building merge requests and retrieving data using our intuitive user interface and simple that can be used by anyone. The second thing is that EVALKits have their own type of visualization, so stored in the same place. So a unified approach. Then we have documented notebooks hosted on the public repository with tutorials to explain how to use the user interface. We try to leverage as much as possible EVALKits, and we allow multi-model comparisons. What we still need to improve, like coming from this last point, is the scalability. So to make the models, so make the three tools easy to modify it, easy to add other models like Destiny, for example, in order to be able to compare the 23 of them, not only the two that we planned, to add other variables that we don't have in the list. Also in the optimization of the performance, especially when dealing with like long durations and long durations, and also for the processing of data. And finally, to apply these tools, to have some tutorials like the case study that I show, to have some tools like so the people can understand that using this tools they can do different things. So that's all from our side. I would like to take the opportunity again to thank our mentors for their guidance and like responsiveness during this 4 months. And thank you.